Hello and welcome to this video on data modeling in Power BI. In a few minutes, I want to quickly show you how to create data model. I'll also explain briefly about different types of data schemas or schemas we have in Power BI modeling. Let's start quickly as I dive into this concept. So, what is data modeling in Power BI? In Power BI, modeling refers to the process of defining relationships between your data tables, creating calculated columns and measures, and shaping your data to support accurate and efficient analysis. Now remember that most times when you have to build some dashboard or data visualization, this data set will come in different tables. Okay, the act of connecting these tables in such a way that it allows for easy analysis is what data modeling is all about. So let's quickly talk about some types of data modeling used in Power BI. Number one, we have what is known as relational modeling. We have star schema modeling. We have calculated columns, which falls under modeling structure in Power BI. Measures. We also have hierarchies, as well as role-playing dimensions. And finally, we have the data categorization and formatting. These are the various types of modeling used in Power BI. Now, let's shift our focus to talking about the schemas that can be created. How these tables can be connected, okay, in Power BI desktop. Now, that is our focus on schema in data modeling. In data modeling, especially in tools like Power BI, data warehouses, and databases, a schema defines how data is organized, especially how tables relate to one another. Just like I said earlier, there are three main types of schemas commonly used, okay, specifically in any of these data connection or data warehousing and Power BI. All right, we have the first one, star schema. For star schema, it is the most popular and recommended schema in Power BI. It consists of a central or fact table that contains measurable quantitative data. For instance, you can have sales, revenue, orders, etc. Now, this fact table will then be connected to multiple dimensional or dimension tables that describe who, what, where, when of the data. Okay, so the dimension tables will always define who, what, where, and when of the data. Example is the fact table can be the sales table that includes the product ID, the customer ID, the date ID, quantity, revenue, etc. So the quantity and revenue are the measurable or quantitative data that actually forms the fact table, while other columns are the primary keys from different dimension tables. So once they are placed on the fact table, they becomes the what's it called now, foreign keys. Okay, and these are the columns that will be used to connect other dimensions. I'll show you this very shortly practically in Power BI desktop. Now, while our dimension tables, which are the products, the customer, the date table, will contain the following columns: the product ID, the product name, the category. And then we have the customers table, which will contain the following columns: customer ID, customer name, the region. And then dates will contain date ID, date, month, and year. Now, this forms the star shape. You have the fact table at the center, then other dimension tables would just place around the fact table, which makes it the star schema, which makes it the reason why it is called the star schema, because it forms the star shape. All right, and with the fact table at the center and dimensions radiating outwards, just like I said. Advantages: it's very simple and fast for queries, great for performance in BI tools, easy to understand and maintain. Okay, let's quickly see a practical application or example of these star schemas right here in Power BI. I've created some sample data and I have my Power BI desktop opened already. So I'll click on blank report to quickly import this data and show you how to create the star schema. I'm going to import the data as CSV. Of course, I have my CSV files already. Once I tap this, I go into dashboard. I save the folder or data set in schema sample data. For star schema, I have the data set all stored in here. Now, these are the data set I want to import. I import the customers table from that. Once I connect the customers table, I'll go again and connect. Let's wait for this to load. So this is the customers table. I just want to load this right away because the data set is actually neat. I load the second table. Let's go to CSV again. Okay, Power BI is still trying to load the first one. Okay, so we have the customers table loaded. Almost done. All right, great. 5 columns. So we have the customers table loaded. I'll click on, let me import the other one. Okay, this is my Power BI desktop. Is taking some time. I wish I can select multiple sheets, but unfortunately I can't do that. I'll import the date dimension. Let's import the date dimension. So here is the table. I click on load because I want it imported directly into Power BI. Okay, so that's imported. I'll import the next table, text CSV products. Let's import the products table, and here is the product dimension. Click on load. This is just sample data set to explain these various schemas. And finally, I'll be importing the sales table. Sales, load. Now we have all of these tables imported into Power BI. Okay, now let's go ahead and look at the model view of this Power BI desktop and to create the relationship if not created already. Okay, in fact, Power BI has already created a model for us, and you see exactly what I just said about the star schema. Now the sales table will be at the center, while other table will form, branches. Okay, they form the kind of branches outside the star schema. I mean the facts table. So here the facts table is the sales table, while the date dimension, the customers table, the product table, and others, they are seen as the dimension tables. Okay, so here is the star schema. This is why it's called the star schema. You have the table, the facts table at the center. Other tables will form just like the branches of the star. Now the date dimension shows you the when. Customers dimension shows you the who, and products dimension shows you the what of the data. So these are various dimensions, and as you can see from the facts table, we have the customer ID colon, which is used as the primary key on the sales table. I mean the foreign key on the sales table that is used to connect with the customers table. So when you place this arrow, when you click on this connection or the connector, you notice that the customer ID on the sales table and the customer's ID on the customers table they are both highlighted, which tells you that this is the key that is used for the relationship creation. When I click on this connector here, you see the date ID from the date table is highlighted and the date ID on the sales table is highlighted, which tells you that it's on those column, on the column date ID, that these two tables are connected. The same thing with the product table. The product column on the products table is highlighted and the product ID on the sales table is highlighted, and that is the common keys. So whenever you want to create a relationship, okay, you would have to first of all create the dimensions, and while creating dimension, ensure that you have identified the primary key or the table or the column rather that will serve as the primary key on these various dimensions. Now find a way to bring in those columns to the facts table. Okay, this is already done from scratch because it's just a sample data. Most times in real life, when you're working on data, on any data modeling or data visualization, you have a flat file, just a large table that you need to then begin to break down into different components or into different dimensions yourself. All right, so this is what I mean by fact table. So Power BI created this for me. Most times or sometimes the relationships would have to be created by you. And as you can see, the type of relationship that's created here is a one-to-many relationship from the date dimension to the sales table, a one-to-many from the customers table to the sales table, and a one-to-many from the products table to the sales table. So that's this one, and asterisk is what shows one-to-many. We'll talk about these types of relationships later on. Okay, so that is that about that. Let's get back to our presentation. Now that is star schema, and I believe you've seen star schema. The next type of schema is the Snowflake schema. This is where you have a normalized version of the star schema. Yeah, the dimension tables are split into additional tables. Okay, for example, the sales table remains the same. Then we have the dimension table products, which is going to be split into dimension and dimension products. Into products and products category table, so that the product will be linked to the products category table, and this product category table can be linked to the sales table. The dimension customers would be linked with the regions table. Okay, and then the structure starts to snowflake as dimension tables branch out. So you have a dimension table connected to another dimension table, and then there's a connection. In fact, in most cases, those connectors are used actually to connect to the facts table, because you may not find a direct relationship between one dimension, say customer for instance, with the sales table. So you need a connector, something that will connect the customers table together with the sales table. So the customers table will then be related to the sales table by a third party. The products table will be related to the sales table by a third party, which is called the products category table. And then you have that. So, but there are advantages and disadvantages. The advantages are, one, it reduces redundancy, which means smaller data size, and then it's easier to update and maintain reference table. You can easily update the tables and also maintain the reference table. But the disadvantage is that it becomes more complex, especially when dimension grows, and then this is slower for reporting tools because of more joins, because you have to do so many joins before you can actually report or get your report from your data set. So that's the Snowflake schema. Now I may not be able to show you practically how this works because of time. I'm trying to make this video really short. Okay, my focus is the star schema. All right, and we've dealt with the star schema. So let's look at the next one, which is the Galaxy schema or fact cancellation schema. So it is, in this schema, there are multiple fact tables sharing dimension tables. You don't have just one fact, you have multiple fact tables. It is used in more complex scenarios like enterprise data warehouses. For example, when you have fact tables like sales and inventory, these two tables are fact, right? And then you share dimensions such as the products table, dates table, stores table, and so on and so forth. Now this creates some it's called cancellation of facts and dimensions, hence the name cancellation, right? And advantages are, one, it's ideal for large integrated data environments. It supports complex analytics, for instance combining sales and stock data. But disadvantage is that it becomes more complex to design and manage, and it requires advanced query handling. So these are the various types of schema that I intend to show you in this video, and we've seen practically how these schemas play out. Okay, you can take your time to study more about schemas in Power BI, and then you have to understand how to create your dimensions. Like I said, when you have your flat file, how to create dimensions from those flat files to actually connect to a fact table, and the connection has to be done really good. You have to understand these facts, dimensions, and fact table for your connections to work. And mostly, we will always opt for a one-to-many relationship or a many-to-one relationship, depending on the angle you are looking at it from. We highly discourage a many-to-many relationship, and you may not want to work with a one-to-one relationship. All right, so that is about schema. And let's quickly give you a summary of what we've spoken about these three schemas. For the star schema, the structure has one fact table and dimension tables. One fact table at the center and multiple dimension tables. That is for the star schema. And the complexity is low. It's best for Power BI dashboards. So whenever you're creating Power BI dashboards, always look out for a star schema. And that is the reason why I took my time to explain that, and I showed you an example. Now, for a Snowflake schema, the structure is normalized dimensions, and the complexity is medium. So it is for the use cases when saving space, it is important to use the Snowflake schema. And the Galaxy schema is has a structure of multiple fact tables with high complexity, and its use case is in the area of enterprise level reporting. So this is a summary of these three types of schemas, and we'll focus more on the star schema throughout our training at DataFad Academy. Thank you very much for watching this video. If you're a DataFad student, I believe you've learned a lot from this, given what we've learned in the live session and the class. And if you are just a random person or a random follower, a fan who follows our videos, thank you very much for watching this. Please do well to like, share, and comment. If you have any questions, we'll get to answer your questions ASAP. Thank you, and I'll see you again in a future video. Goodbye.